refraction we can have when transmitting electromagnetic wave. Okay, this is an incident wave, is the one that you see here coming in. Okay, then when it has been absorbed, it's gonna go, it will continue, but it's not gonna have the same power or quality that it has before. Okay, when we have an obstacle, and there will be some sort of refracted wave. Okay, so that's what you see there. And here's another example, just to give you an idea of the type of wave, when we have an obstacle and there's an incident wave, there's a block that is blocking the signal. The signal will be absorbed and then refracted. Just to, the same apply for this signal. The incident wave is gonna come here and it will be reflected in that direction. Okay, so just to give you an idea. And this is also another, the signal will be absorbed here, the region for the signal, and also this is what we say reflected ray. Okay, the same goes for this. The signal will come and will be refracted, and there's, if we have an obstacle here, if the signal goes there, the signal will be absorbed. Okay, so, and that's what you see, an incident wave, and then it will be absorbed, and then we get something on the output, but it's not gonna have the same quality as it used to be. And this is an example of refraction that you see here. Okay, in simple term, when we transmit a signal, right, this is a transmission, and when the signal we receive the signal exactly how it is, we call it transmission. And this one is refraction. Refraction is when there's an obstacle and the signal is reflected. And refraction is when the signal goes in between. It's reflect, but it's going to go inside the obstacle. Okay, diffraction is when the signal is goes into a hole and then it's now duplicated into multiple direction. Okay, and this is absorb. Absorb is when the signal goes inside and it's decreased, but it's going to continue, but it will be decreased in some ways. And scattering, it's when the signal come to one point and is sent into different direction, as you can see here. So now the signal will be scattering. And the application of refraction, you can see this is the transmitter. Okay, and when we send the signal in this direction, and if there is a mountain hills, the signal will be refracted. So then it's going to be sent to our receiver, but it's not going to be the same as it was at the transmitter. Okay, so that is just an example of a case of a wave refraction. Not just refraction, it's diffracted. So the wave is going into multiple directions. Okay, we just correct that. So this is diffraction. So the wave, it's going on after this obstacle, and this is another diffracted wave. So this one is a transmitter, and that one it's a receiver. The signal will be sent, and if there is a hill, mountain, the signal will be diffracted into multiple directions, as you can see now. Just to give an idea of what is attenuation. Okay, when the signal comes, there is an obstacle, the quality of the signal is attenuated. Okay, when a signal comes, goes inside, and this is absorption. You see the signal is going to be absorbed, and maybe at the output we're not going to get any signal anymore if the absorption it's bigger than what we were expecting. So now this is refraction. When signal goes and it's refracted into the other direction. And this is multiple path propagation interference. That's what you see here. Now this is a transmitter, and this is where we need, you have your TV, and then you need to receive the signal from the antenna. You have a TV station somewhere there. Okay, and this is, you got your TV and the antenna on top there. Okay, and this is diffraction. When the signal is gonna come, it will be sent from the antenna. Once it's gonna get to this fields, it will be diffracted into different directions at the same time. The same goes for this. When the signal comes here, when there's a small hole, it will be diffracted into this direction with this angle. When there's a big hole, it's not going to be very much, but it's going just to be diffracted. Okay, so this one is the incident wave that goes, and then it will be these are just the case, and these are just the case scenario that you may encounter. Okay, this is the refraction of the signal by the hill, for example. This diffraction of the signal that's giving some case scenario, ground wave transmission, and this is a transmitter, and that's the receiver. You can have maybe a building refraction, hill refraction, house refractions, in order to get to the receiver. And this is the iosphere. That can also be a way to reflect the signal. Okay, and if the signal goes above the iosphere, this is just to give you also another case scenario on what. Another example, if you have to send your signal to the space. Okay, if the signal goes past the iosphere section, okay, but if the signal is reflected like here by the sky wave, that's an example of what I'm just saw, an application of the signal. This is diffracted of the signal that you see, the same signal. And this is an example. Imagine you have to send a signal. That's a transmitter and the receiver, and there is a building as an obstacle. The signal will be a multiple path propagation effect. Okay, this is just asking you a question. What's going to be refraction, diffracted, scattering? This is a question that you can answer when you say this. Okay, and this is where the signal is sent into different directions. Okay, and this is transmitter, and we have a obstacle. When the signal leaves the transmitter, and in order to receive the signal here, you're gonna see that there will be a this is like the signal. Okay, and in case we have a diffraction point, the signal will be sent into different direction.